All right, in this video, I'm just going to quickly kind of talk through how to conduct a hypothesis test when you have two different population means that you're comparing. Okay, so we have one data set of 16 observations from the first population, another data set of 17 observations from the second population. And what we want to test is the mean from the first population different than the mean of the second population, right? So if you were to write this out, your null hypothesis, you always have the equal sign. So is the first mean equal to the second mean? Null hypothesis always has the equal sign. The alternative hypothesis would be that they're not equal to each other. So you could write that as not equal to mu2. All right, so that's what we're trying to test. Let me see if I were to go insert, I might be able to insert that symbol better. So I'm saying not equal, there it is, okay. Close. So I'm saying not equal, right? There's the equal sign with a cross through it, or a slash sign through it, right? All right, so how would I do this? How would I test this hypothesis? Now we're going to assume the populations are normally distributed and we have unequal variances. All right, and we're going to use alpha equal to 0.05. So first thing, go up top to this data, click on data, then click data analysis. All right, and we have two different samples. So there's a few choices here. We have the paired two sample for means. That is for paired data. Okay, so paired data is like, say I'm interested in lowering someone's blood pressure, and I measure their blood pressure before I give them a drug, and then I measure their blood pressure again after I give them a drug. So then I have before and after type data, right? But it's the same person. So that's like paired data, right? So it's two different populations in that you have a population of data that's coming from people before they've taken the medicine, and then a population of data coming from people after they've taken the medicine. But it's the same person, so that's paired data. Okay, now a really good hint that this is not paired data is that we have different number of observations. So this first data set only has 16, second data set has 17 observations. Clearly this isn't paired data. But unless they're specifically telling you that the data is paired, it's probably good to assume that it's not paired. So then we're looking at these two down here. So assuming equal variances or unequal variances. Well, they told us that we want to assume unequal variances, so that's what we want to use. So let's click on that and then press OK. Okay, variable 1 range. Okay, click, hold, let go. Okay, variable 2 range. Click, hold your left clicker, drag down, then let go. Hypothesized mean difference. What this is usually it's always going to be 0. Unless you're interested in knowing is the mean from one data set a certain number, like less than the other data set, for example. So like, did I lower their blood pressure by 10 milligrams of mercury or whatever the unit is for blood pressure? So you might be interested in knowing, is it this much lower? Is it like 10 lower? But most of the time we're just interested in knowing, is one more than the other, or is one less than the other, or are they different from each other? So usually the hypothesized mean difference is just 0, right? Okay, labels, you should click that because you should, when you highlight your data, include the label, okay? So you notice I started A1 to A17, and then for variable 2, it goes from B1 to B18. Output range, put your cursor in there, click that, then click on a cell. All right, so it's going to put all the output here. Press OK. All right, now we have a two-sided test because you see that not equal to sign. So we're interested in the two-tailed p-value. All right, now the two-tailed p-value, so first off, looking at this really briefly, we see that the mean from the first data set is 5, the mean from the second data set is 10. So yeah, these are quite different means, right? And when we look at this p-value, we see, okay, remember this e to the negative 6 means we move the decimal 6 points to the left, right? So that's 0 0.1, 2, 3, 4, 5, 6, right? These are the same numbers, this one and this one, because that's what that e to the negative, I mean, you can see it up here, actually. Here it is. You can see it up here. So it looks like there's 1, 2, 3, 4, 5 zeros and then a 6. So yeah, that's a really small p-value. Is it less than alpha? Yeah, it is. It's less than alpha. So our decision, when you have a really small p-value like that, it's less than alpha, your decision is going to be to reject HO. And then, since you've rejected the null hypothesis, so you've rejected this guy, right, that's going to mean that you are going to be like, okay, well, there must be evidence for the alternative. So there is evidence to suggest that the population mean 1 is different than population mean 2. Okay? And then that's all there is to it.